So my name is Hans Panjard. I'm the chairman of this chapter for Silicon Valley of the Computer Society. Before we go into introduce Marco and his presentation, again, there was a slide that Anne went through, is about volunteering. So this type of events we can only do because there's people who are interested enough to drive this and make sure that this happens. And me, and you saw a couple of people out there who help organize this. So this is all volunteer work. You get paid in pizza, and you get paid in what I think is excellent networking, professional network opportunity, which is much better than the pizza, I can tell you. So out of experience, I can tell you that if you are interested to expand your network, doing this via IEEE and wearing an IEEE hat, which I'm today not wearing, is actually a very good approach of doing that. We are serious that we need volunteers. We need volunteers for pretty much everything in the end. We specifically need volunteers for officer positions. So there's a chair, there's a vice chair, there's a treasurer, and a secretary, and that's the way we like to fill the 4 officer positions every year. We are still interested in a number of people who might be interested to run for that. I would love to see that multiple people are contending for one single seat, so we have a little discussion if possible. Either way, anyway, you're always welcome to help out, organize. If you have initiative, you want to organize a symposium beyond what we're already doing, go ahead. You're always welcome to join in and come up with proposals. We need energy, we need enthusiasm, and your time in the end. So talk to me, and can all volunteers who are currently here stand up, please? We have Trevor there as the current secretary. We have Ram somewhere. We have Ram over there. We have Kevin on the end there. So all those folks there you can talk to and ask questions how great it is to be part of this organization. Let me introduce Marco. So Marco is actually somebody who we see every year, pretty much around the same time. He's now the director of Twitter University, not so much last year. I think that happened all in the last 360 days. Where he helps educate Twitter engineers on the cutting edge Android and other technologies. Prior to selling Maracana to Twitter, Marco was the developer of Maracana Android training series, and that's where we know him from, and that's why he shows up every year here and presents. He has taught Android to more than 1,000 developers at many big companies like Cisco, Intel, Motorola. He's the author of the Learning Android book, published by IEEE Media. The book is based on Android Bootcamp and incorporates best learning practices for new developers to start creating applications. He frequently speaks at conferences and events such as OSCON and DEF CON, a lot more IEEE in general, and here. He's lucky enough to live in San Francisco, California. And welcome to Marco.
Thank you, guys. Let me just hide this and start this. So just really quickly, how many of you are Java developers or develop something in Java? Okay, so about half. And how many of you are planning to follow along, downloaded SDK, installed stuff? Just a handful of you, meaning like you actually have a computer in front of you. That's a handful. Okay, got it. Cool. So so today we're gonna do. We have a very limited amount of time, and we're gonna just dive deep into building something in Android. Hopefully, it's gonna work. I'm just gonna code everything live. So all I did beforehand is what was sort of asked at the description of the event, which was to go to developer.android.com, and I simply went to develop, tools, downloads, and I downloaded the SDK bundle. SDK bundle is basically a combination of Android SDK plus Eclipse, which is the tool that we currently use for Android development. In the future, it's probably going to be something called Android Studio, but that's still in an infancy, which is based on IntelliJ. So I'm going to be using Eclipse today, but just so you know, in the future, it may not be Eclipse anymore. So what I'm going to talk about is how to build a simple application. So basically, I downloaded this tool. I did this prior to you guys eating pizza. And so I launched Eclipse, and this is what it looks like. So it's Virgin. I haven't actually used it yet. So what I'm going to do is I'm going to create a new project. And basically, so this is Eclipse that is aware of Android SDK. So it's got the ins and outs of the SDK already kind of plugged in it, thus the word bundle, right? So I'm going to go File, New Android Application Project. So, and I'm going to basically start developing an Android project here. I'm gonna give it a name. Let me kind of zoom in here. So I'm gonna give it an application name. This project I'm gonna build is an application I built for training purposes. I call it Yamba, which stands for Yet Another Microblogging App. It's basically a toy version of a Twitter app. So I'm gonna call it Yamba. And this in here is just an English name. It doesn't have any significance to it. Project name, the next one along, is basically the name of the project within the Eclipse space. So this is now an Eclipse construct. Also not as significant. Now what is important is going to be the package name. The package name is basically the unique identifier of this app. You can only have one app with one package name per Android store, such as Google Play, or per your device. So you can't have two applications on the same device with the same name. So there isn't sort of like a centralized place to kind of verify if the name is taken or not. But in practice, if it's taken on the in the store, you're going to have a hard time releasing it. So this name is significant. A lot of security things are keyed off of it. Now, it just follows a standard Java naming convention. So I may call it, for example, com, Twitter, Yamba, for example. Just basically, it's the reverse of your name, domain name, as in how you would call it in Java. Now, the next couple of things that we have to decide on are sort of business decisions. It's basically what is the minimum SDK that this app is going to require. In other words, what are the minimum set of requirements that we expect from a device on which this app is going to run? So, of course, you can say I'm going to support as old as very first version of Android, but there's a certain cost associated with supporting very, very old things, right? It's sort of like in the world of web. If you're programming for, say, IE 6, there's a certain cost associated with maintaining old legacy browsers. So most of us are trying to target as latest as possible, but at the same time, we're sort of aware that this is, like I said, a business decision. And to kind of show you what that means, I'm just going to bring up the so-called dashboard, which is basically a live chart showing us what the distribution of Android operating system versions globally are. So as you can see, we have most of the world now using Jelly Bean. This changes quite frequently. But we still have some amount of people still using a very old version, version 2.2, aka Froyo. That's a couple of percent. Maybe we don't care about that. We're going to then focus maybe on Gingerbread as a minimum, and so on. So you basically get to draw a line where you're going to support, how far you're going to support back your application. So I'm gonna assume we're going with, say, Honeycomb. There was sort of like a big change in Android, or significant change in Android with Honeycomb, also known as API level 11. So I'm going to go with that. Now, the target SDK is usually one of the latest versions. So in this case, 18 is Jelly Bean is the latest one that I have. Compile with is typically the same as the one you are targeting. Sometimes it may be different because of some bugs in the SDK and so on, but I'm going to leave it at the same. And the theme is not as important. Think of the theme as a CSS style sheet in a web page. So basically determines the look and feel of the application. Is it black on white, white on black, bluish, that sort of thing. So I'm just going to go with the default hollow light with dark action bar. So that's kind of like a default Android application. So next what I'm going to do is I'm going to click on next. And on this screen, it's basically just asking, hey, do you want to create a custom launcher icon? And do you want to create an activity? We don't really know what activity is yet, but don't worry about it for now. I'm going to click on next. I haven't changed anything here. And it's asking me to create an icon. This is going to be the little icon that you touch to launch your app. So I'm going to, I can either pick something from a clip art or, for example, I can pick maybe a little droid, and I can pick a color. So I'll make it like lightish blue, something like that. And I'm gonna put it in the middle. I'll say it's gonna be in a circle, and so on. So I'm kind of like just customizing. Obviously, you can have your graphics designer friends or colleagues do a much better job. But the point that I want to show you here is that I'm not creating one icon. I'm actually creating 4 different versions. So this tool is actually helping me spit out 4 different versions of the same icon. And they're kind of coded. There's MDPI, HDPI, XHDPI, etc. So what that stands for is medium density per inch, large density per inch, extra large, and so forth. So basically, these devices, they come with a different density of the screen. When the first Android came out, HTC Dev 1, it had 160 dpi, dots per inch. Nowadays, the modern devices are pushing 300. Nexus 10 has 400 plus dots per inch. It's crisp, clear when you look at the screen. So to accommodate that, we need to basically have more pixels to show an icon of the same size, right? And Android, as you guys know, unlike other mobile devices, runs on many different mobile phones, right? Just to kind of, I'm gonna use some slides just to kind of drive some points, but I'll show you what I mean by that. So basically, what happens is in the world of Android, Google ships out an official version of Android, right? And right now we have about 19 official versions of Android, right? And then you have manufacturers take these official versions of Android and then customize them. So think Samsung with multiple versions of Galaxy, HTC with multiple versions of whatever they call their devices, LG, etc., etc. So basically, let's say we have 5 major manufacturers or 5-10 major manufacturers with 5-10 versions each. So we're looking at about 20, 30, let's say 25 versions of different, actually I was going to say more like 100 versions. So let's say 19 times 100 versions of different phones out there, right? And then you have carriers, Sprint, Verizon, AT&T, and so on. They also modify Android. So let's say in the US we have 5 major carriers. So by the time Android gets to a consumer, you have a combination of all these, right? So a service such as Pandora, they actually measure how many different devices are touching their service, and that number is about 10,000. Right? So we're talking about 10,000 different combinations of operating system and sizes of screen and types of devices and chipsets and et cetera, out there. So it's probably the most fragmented computing environment on the planet, right? So to deal with that, we basically need to address multiple possible screens, and that's why we're having 4 different icons here. We will see how this plays out later on. So I'm happy with this icon. I'm going to click on Next. Now it's asking me to create an activity. We don't know what an activity is yet, but for now, just think of an activity as a screen. So it's going to be a single piece of UI, a single screen. Kind of like, in a website, it would be a single web page, right? So I'm gonna go with that. I'm gonna create a blank activity. I don't want to start with like a whole bunch of crazy things and confuse you. I'm just gonna start with a blank page. So I'm gonna click on Next. And now it says, all right, well, you're creating an activity. What do you want to name it? And it can really be anything. Since we're building a little Twitter application, I'm gonna create an activity from which I'm gonna tweet. So I'll say tweet activity. Now, whatever I put in here is going to become a Java class. So I should adhere to Java naming conventions. So that's why I'm using the camel case. And whatever I put here is going to be an XML file. There isn't a clear convention here, but this tool is suggesting underscore to separate the words, so I'll go with that. And I'm going to choose none for the navigation type, because I don't want too much boilerplate code, again, to confuse you. So I'm going to click on Finish. I don't have any other options at this point. So this tool is now creating our application. Hopefully the tool works. And it's basically creating a whole bunch of boilerplate code. And it's still loading. And it should be loading fairly quickly. So what we have here is now we have an application. I'm going to give you just sort of like a quick rundown through this application, what it is. And then we're going to basically go into modifying it. So this is, let me kind of close this that was open for us, and I'll open it later on. So basically what we have here is we have the app. So we got a whole bunch of boilerplate code. And in the application is roughly broken into some Java code and some code that's not Java, which we call resources. And then there's a file called the manifest file, right? So the manifest file is sort of the big picture, the big meta information about your app, right? It kind of says your app has this and that, and it kind of explains your application. So resources are things that are not code. So your app is going to need obviously some code, but it also needs some things that are not code, like images, graphics, HTML, or XML resources, etc. So that's going to be in here. As a matter of fact, our icons are in here. Remember the icon that we created, the little droid that was baby blue in a circle? So it's right there. So basically, you take, at the top of that, we have Java. So basically, you take this Java, you take these resources, and you take that manifest file, you add them all up, and you basically get an APK file. APK file stands for application package, and that's basically your Android app. It's essentially a zip file. It's a single archive, which you now submit to the Google Play, set a price, and watch a million people download, right? So that's kind of how that works. So let me roughly show you this app. So basically the manifest file, Eclipse knows that this is a certain type of XML file that it understands. So it opens it up in this like sort of WYSIWYG tool. So let me kind of close this. It kind of lets us edit this file by clicking on the little tabs and so forth. But ultimately, it's just a piece of XML. It's usually not that long. Don't worry about the details, but as you can see, it kind of says, well, we have a manifest file, and there's the application, and that application has an activity, and there's certain things that we set, like the minimum version and the maximum, the target version. We set the package name, and so on. So it just kind of describes the meta information about our app. So I'm not going to be modifying anything more in this file, so I'm going to close it. Now, resources are anything that's not that lives in this directory called res, and that's everything that's not code, right? So I already mentioned we have our icon there, but we also have other things, like, for example, pieces of text. So text is or shouldn't be code. It should be outside of code, so you can easily change it. So, for example, the actual app name is here, right? It's actually defined as a piece of text. It's a name-value pair, right? Again, Eclipse is doing this kind of hand-holding, helping us understand what's going on. But behind the scenes, it just looks like this, right? So you have basically some kind of piece of text, which is a name, and then its value. Okay. So that's a little bit about resources. You can have multiple versions of resources. So for example, if I wanted to quickly translate my app into, say, Spanish or French, or for example, French for Canada versus French for France, I can basically just provide alternative versions of these resources. So that's what these dashes in the directory names are. So for example, we can see that with our icon. Remember when we created an icon, we actually created 4 different icons. So there they are. There's icon 1, 2, 3, and 4. Right? So it's the same icon. It's just the difference is the actual extension of the folder, which tells the system which one to load, depending on what kind of a device this app happens to be running. So medium, high density, and so on and so on. So that's a little bit about resources. Now, as you design these resources, you are going to need to refer to them from Java. So there's a file called R. It's an auto-generated file, and it's pretty ugly. You don't ever actually need to look at it. It's just a bunch of integer pointers. But basically, the goal of this file is to glue the world of Java to the world of resources. Okay, so you hopefully never have to look at this file. I'm going to close it because it's not that pretty. But basically, it's helping Java find your other stuff that's not code, right? So let's finally take a look at Java, because that's the top dog. That's what actually runs. And as you can see, I'm gonna turn on line numbers, and I'm gonna get rid of this because it's noise. That was a piece of code that was just given to us by the Eclipse tool, so I haven't actually written it. I want to kind of keep it as minimal as possible. So as you can see, we have a piece of code. It's Java code, and it basically it's our tweet activity. And remember, activity is roughly a screen, and basically it's subclassing something called an activity. So we're starting from something that system already gives us, right? And then we're extending that. And we're extending that by overriding the default on create and calling it super. Okay, so we subclass something and then overrode the method and called whatever the parent was going to do. So essentially, until line 11, we got nothing new, right? It's a status quo, right? So the only significant line in this whole thing is the line 11. So what does it do? So this line basically says, set the content for this view. In other words, like activity is a screen. So set the content for this screen, right? To our layout main. Let me show you what that really means. I'm going to kind of open this up so you can fit it on the screen. Remember R is that file R that I told you it's ugly file. You never have to look at it, hopefully. So our layout activity tweet. So this is how we use R to point to something that's not code, to a resource. So basically what we're doing is we're here from this file, right? That's this file. We're pointing to a resource, a layout activity tweet, right? So basically our layout activity tweet maps to res layout activity tweet. So this is essentially a pointer to that file, okay? So we're basically saying in Java, hey, load that XML file, okay? So now we're getting to the actual XML and what that looks like. So you've seen sort of like the strings XML, right? That represented pieces of English language text. Let's take a look at this file that we're pointing to. So this file renders like this. Again, it's one of the XML files that Eclipse understands. Okay? Behind the scenes, it's really just an XML file. Okay? So think of this tool sort of like, anybody used Dreamweaver before, or Front Page or something like that, right? Like you kind of flip-flop between the WYSIWYG and the HTML. So it's very, very similar, analogous, right? So we're basically working on XML, but Eclipse is providing some hand-holding by giving us a view that's slightly more intuitive. So this looks like a screen of a phone, right? And you can adjust if you want it to look like a screen of a tablet or a different form factor, etc. I'm not going to worry about that. But I could, for example, just drag some widgets from here, like maybe I want a radio button, and maybe I want a seek bar. It's a little scroller, and maybe I want, I don't know, time and date, for example, date picker, so I can pick a date, and maybe calendar view. I'm just kind of drag and dropping certain things, right? So it's very similar to what you did in HTML, in Front Page or Dreamweaver. Now, behind the scenes, what's happening is just basically building that XML for you, right? So it's just basically creating these elements. So this is not the view that we want to create. So I'm going to kind of go back and delete all these elements because I don't really want them. This is what we started with. We just had a piece of text called Hello World. Now, for those of you familiar with the web browsing, or web development, you know that a web page has equivalent of a DOM tree, right? So you can kind of see like the root of the web page and then how it branches out into all the components. So we have a view that's very analogous to that right here. So basically it's showing you that I have a relative layout, and then that relative layout contains a piece of text. And right now that piece of text is selected, so that's why this is now selected here. If I select relative layout, I'm basically referring to the entire screen here. Okay? So this is the mother of all, the entire big white box, okay? And then this is the small screen. Now, before we actually go ahead and design this, so far I haven't changed the line of code, right? This is all boilerplate so far. I'm just going to go ahead and run it so I can actually show you how this works. Now, I could plug it into my phone and run it on a USB, but it's going to be really hard for you guys to see it. So instead, what I'm going to do is I'm going to run it on an emulator. Okay. So now Android ships with something called an emulator, which is it's kind of like a simulator, except simulator basically fakes the execution of your code. Emulator actually is kind of like a virtual machine. It emulates the underlying hardware. Like you can pretend you're running ARM binaries on your Mac or PC, right? So basically what I'm going to do is I'm going to go ahead and I'm going to create an emulator. So I click on this little button here, and it opens up something called Android Virtual Device Manager. I'm going to click on New, and then I get to create an emulator, or more specifically, Android Virtual Device, because I can have many of these devices. Maybe I'm developing, and I don't know, I want to test on like different form factors. Like, what is it going to look like on a tablet, or on a big screen TV, or on a tiny little phone with hardware buttons, and so on. So you can basically have multiple versions of this, these virtual machines. So you give it a name. It could be anything. It could be like my phone, for example, or maybe you call it Nexus 4. I'm testing for Nexus 4. And you kind of have like a pre-canned versions of like some generic devices, but this is totally optional. This just kind of helps you set up the parameters for your device. So let's say Nexus 4. Then you pick the operating system, one of the operating systems that you downloaded that's installed on the device. So I only have one, Android 18, which is the latest one available. Then I pick the architecture. So I happen to have Intel downloaded as well. It just happens to run faster obviously on Intel chipset. But you can also try ARM. That's actually the default one. And then you can say if you have a keyboard, if you should use the hardware keyboard. If you want to fake one of the cameras, like front camera, back camera. Specify RAM options, specify a little bit of an SD card just for test purposes. And you basically click OK. Okay? And that basically now creates a device for you. So once you have the device, you can just click Start and you can launch it. I actually already launched mine, so I can show you the actual device running. So this is the vanilla device that I just created a couple minutes ago, right? So now what I can do is I can press this little green button, okay, on my here. And actually, let me see, the little green button is not working, so I'm going to go by, sometimes Eclipse is just buggy, so sometimes if the little green button doesn't work, you can right-click on Yamba on top of your project and say Run as Android app, right? So now that's basically behind the scenes compiling, creating an application, signing everything, and launching. Okay. Now, first time around, it's actually asking me, hey, would you like us to start logging what's going on? So I'll say OK. So that's now logging what's going on as well on the device. And there it is. There's my app actually running. It's not doing much, but this is actually live on an emulator, and it would be the same thing if I ran it on the phone, right? So that's basically my app. It doesn't do much at all at this point. So what I'm going to do next is I'm going to design the user interface. This tends to be sort of like the more interesting part. So we're going to basically design a simple tweet activity. Like, you guys may not be using Twitter, but it's essentially where you get to type in a message, click a submit button, and it posts it to a cloud, right? So that's what I'm working on. So I don't need this piece of text, hello world. I'm going to select it and click delete and get rid of it. So what I do need is I need a piece of text when I'm going to type. And I need a button to click to tweet. So I'm going to find a button. There's a button right there. I'm going to kind of drag it to the top left corner and drop it in. So there's my button. Something is off with it in terms of the actual text of the button, but hopefully that is nothing significant. Let me actually do this again. I think this is just a bug with the tool. So I'm going to just redrop it in. Interesting. So what I'm going to do with this button is I'm going to set its text. So there's a little piece of text here, okay? And normally I would just say the word tweet, okay? Except this is not positioned properly.
Probably have a property that says right align.
It's actually centered. It does run it. But when you run it on the emulator, it'll be centered within the button.
Right, so let me remove this altogether, center vertical, let me see what it is. Left margin top, delete that. And, well, it's probably just a bug with the tool. Let me see what it shows up when I run it. So I'm gonna just double check it again and see what it appears like when it actually runs. So it looks like it's okay here, but for some reason it just doesn't appear nice here, and it's a minor bug with the actual tool. So I'm going to position it as I wanted to position it initially. Okay, so it should when you run it, it should look like this, basically. So it's a tiny little button that is going to be in the top right corner. There it is. There it is. Now, when you drag one of these widgets over, you have basically gazillion properties that you can set on any widget, any particular widget. There are two properties that you absolutely must have, just two: width and height. Okay, and basically the width and height could be hard-coded. You could say so many pixels. That's probably a bad idea because we already know that pixel could be very different unit on a different device, right? Android comes up with an alternative unit called a DP, which stands for density independent pixel, DP or DEP. Now, so that would, and you see that sort of like in like dimensions like this. I'm not sure actually why it's actually even putting in there, but those are calculated. So that's a DEP. Now, the best way to specify the width and height is actually to make it one of the following two. Either it matches its parent, which means it takes all the available space, or it wraps its content, which means it takes as much space as it needs to wrap its own content. So this button, for example, it's wrap parent both horizontally and vertically. In other words, it's supposed to wrap that word tweet, however that word is, right? So if I wanted to expand it like this, it would basically now be much longer, right? So it's basically it's going to take over the entire space. So that's basically, those are the options that we have for the button itself. And I'm just looking at if there's anything else that I want to get rid of. Okay. So in this case, I want this button to basically be shorter, and I want it like that. Now, the word tweet in this case is hard-coded. I went ahead and I typed it here. This is not the best practice because now my layout, my screen is concerned with English, right? And it shouldn't be because it's going to make it hard for me to translate this application. So what I should be doing instead is I should be outsourcing the actual text into my strings and then referring to it, right? So that I can have, like, in case I want to run my app in the Spanish market, it would automatically pick the Spanish text and resize everything accordingly. So basically, what I'm going to do is I'm going to click on this dot, the little dots next to the actual piece of text. And as opposed to hard coding the piece of text, I'm going to say new string. Okay? And now it's asking me for the name and the value of that new string. So basically, the name is going to be how it's going to be known internally to the system. So tweet, for example, or I can, just to kind of make it distinguishable, I'll say text underscore tweet. Okay? So that's not what's going to show to the user. That's just an internal to me, to my, as an app developer. What I wanted to show is to user in English would be tweet. Now, if I was using some other language, I would basically go and I would say, I want to specify the language to, for example, Spanish. And then I would provide the Spanish version. But I'm not. So in this case, I'm going to basically stick to English. I'm going to click on OK. Now, the result is going to be the same, but now this is properly encoded. Secondly, what I'm going to do is we need a piece of text where we're going to actually type. So I'm going to find a text field, and they're all basically, so basically what I can do is I can say either a number or a password or a multi-line. Let's say we're going to put a multi-line piece of text. And in this case, I'm going to expand this to take all the available space. So I have a big text area and a button to the top right. So this is a sort of like a minimalistic UI. Okay. So next what I'm going to do is I can optionally provide, we're not going to provide a piece of text, but I can optionally provide hint. Hint is going to be the text that is there, and as soon as you start typing, it kind of disappears, right? So I'm going to use the dot, dot, dot again, click on new string, and say text hint, for example, and I say what's happening, for example. So that's going to be the text that shows up here. And I could position this text, for example, if I wanted to via gravity, which is giving me problems on the other one a little bit. Via gravity, I'm going to click on the little dot, 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 and I'm going to say I want it to the top center horizontal. So it's going to, I'm not sure why it's center horizontal.
It'll be right on the emulator. It's just a
Yeah, it's a bug on Eclipse, but it should look like that. Okay, so at this point, I basically have this UI looking correct on a device, right? It's a very, very simple user interface. Now, let's imagine we're done with the UI. Of course, we can do a lot more cosmetic stuff, but just in the interest of actually moving on to Java, we want to now implement the logic of this code. So as you can see, XML is a good tool to kind of describe what your UI looks like, but it's not really a good tool to say what the UI does, right? So in XML you can say, hey, I have a button, and it's position, and it's gray, and it's got this text, and it's in that corner, but you can't really say what the button does. Right? Java is much better for saying what the button does. So what I'm going to do is I'm going to switch over to Java. And basically what's happening here is after this line 11, if you guys remember, we so-called inflated that XML. So essentially after this line, we have now our XML in Java. So XML is really disposable. It's just there to get Java going, right? So next what we need to do is we need to find the widgets which we care about from XML. So, so we're going to bind the widgets to one another. So what I'm going to do is, to be able to do that, what I'm going to do is I'm going to give my widgets IDs. Okay? It's very similar to what you would do when you're connecting HTML to JavaScript, for example, in a browser. So I can do it either via this screen here and specify the ID. You can also right-click and say, I want to change the ID of this button. So I'm going to call this button, for example, button tweet. Okay, and so I give it an ID, and I'm going to do the same thing for this. I'm going to right-click, say edit ID, and I'm going to say edit tweet. Okay, so this is going to those are going to be my IDs, right? So next, now that we have these IDs, what we can now do is we can find these widgets in Java. So I'm going to give a variable. I'm going to create a variable that refers to them. So I'm going to have a private. And by the way, the names of the types are same as the names here, types here. So button is going to become a Java instance of a class button, and edit text is going to become an instance of edit text. So I'm going to go here. I'm going to say private button button tweet, and I'm going to say private edit text edit tweet. So now these are my Java widgets. I'm going to basically say source organize imports, or Control-Shift-O to import those elements there. And now what I can do is I can find them. So after this line, like I said, XML is actually really became part of Java. So what I'm going to do is I'm going to basically say button tweet is going to be find view by ID. And now I'm using R, which is, remember, R is the glue between the world of Java and the world of XML. So r.id.button tweet. So that's now my button. And by the way, you need to cast it, so you need to add a cast to convert it from one type to another. And next what I'm going to do is the same thing for edit tweet. So I'm going to say find view by ID, r.id.button tweet. and I'm also going to add a cast. And so now we basically have those two widgets, right? So now that I have those two inflated in Java, I can now program them. So basically what I can do is I can say button tweet. I'll basically say set on click listener. So basically what I'm doing is I'm adding a listener to this button. So I'm saying, hey, button, when you get clicked, call somebody, right? And that somebody could be this very class, right? So I'm basically saying button call this very class. So this refers to the tweet activity. Now Eclipse says, hey, this is not valid because tweet activity is not callable because it doesn't implement on click listener. You can right click on this and say, basically say let tweet activity implement on click listener, which now essentially just adds that there. So it says, hey, this is an interface on click listener. So next what we need to do is we need to basically add the unimplemented method of that listener, which is that this method on click. So in other words, when you click on a button, button is going to notify tweet activity because tweet activity is on click listener implementation via calling back these methods. Okay, so Eclipse kind of provides a lot of hand holding here with this. So we now know that this button is going to get called when we click on this. Okay, so now that we have that bound, what I can do is I can extract the piece of text that was clicked on, that was typed in. So I'll say string tweet. So this is the piece of text, and I'm going to say tweet is going to be edit tweet. So edit tweet, right? Dot get text, and then I'm going to convert it to a string. Basically, I'm now, since I have a Java reference to that widget, I'm saying what's the piece of text in that widget. So now I have it in Java. Okay. So now in ideal world, I'm ready to tweet this. Okay. So how do we do that? Twitter uses a RESTful API, so it's HTTP call. So I would need to open up HTTP and so on. Now that piece of how that works is very well documented, and it's just a plain old Java. There's nothing really new and different how you make a RESTful web service call. So instead of kind of going down that whole how do you actually do that, we kind of shrink wrap that into a tiny little library. So I have this library called Yamba client lib, which I just copied. So let me just find it. Yamba client lib, and I'm gonna just drag it into my project. You can download this library, or you can Google it. It's relatively easy to find multiple implementations of Twitter API Java libraries. So I'm going to take this library that I found online. I'm going to drop it into my libs folder. Okay. So libs folder is a special folder that Eclipse understands is going to be part of your libraries of your project. So now that I have that, I can basically say Yamba client. So I'll call it this Yamba. I'll call it cloud. Okay, so cloud is going to be new Yamba client. Okay, and I'm going to import it. So notice that now imported that library. So there's a reference there. Oops, there's a reference there to that library. So now that we have that imported, I happen to know that this one takes username and password. So just a quick word on this. We're not using a real Twitter service because of the restrictions like simple like username and password and so on. So we basically created an alternative service that uses the same API, but we can just bang against it as much as we want for learning purposes. And that one is called yamba.maracana.com. It's a toy Twitter for our toy client, so that we can easily tweet and not be restricted by rate limits and usernames and restrictions like that, right, for learning purposes. And keep in mind that a lot of people who are using my book and other research, so there's a lot of sort of people using that service, so there could be some spam and things like that. So the username and password are very well known, so it's student and password. So that's the username and password. So now that I have that, I could just say cloud dot post status, and I can say post this tweet. Okay. In this case, it's actually the API is forcing me. Let's see, it's forcing me to surround this with a try catch block, because when you're connecting to the cloud, things could go wrong, right? Service is not available, network is not available, username and password are wrong, gazillion things could go wrong. So I gotta catch that exception. All right, that's fine. So Eclipse does that for me. So if I run this, in ideal world, this should work. However, it crashes for us right away, right? Now, a class cast exception. Okay, so this is actually different. So we're basically crashing right away, and let me. Okay, I casted it wrong. Got it. So basically, button edit tweet. This was the, yeah, so this was edit tweet. Got it. So basically, I tried to convert an apple into an orange, and surprisingly, that did not work out. So I'm going to rerun this. Okay. Now, this is going to start, okay, but it's going to crash. I'm just warning you right away. So if I say hello, okay, click on tweet, this is going to crash. And it didn't crash. So, but it didn't either work, right? All right, so let's see why it didn't crash. So I'm going to look at the logcat. Okay, so the logcat is basically telling us what's going on with our application while it's executing. And what we can do is we can basically put a little log notification so that we know where we're at. So basically what I'm going to do is I'm going to say log.d for debug. I'm going to say that we are right now in tweet activity. Okay, and I'm going to say that we're at the end of on create, right? And I'm going to import log. Okay, and here I'm going to say that we are in on click. Okay, and I'm going to run this and see basically which piece of code actually executed when we click on this. Okay, so on create executed, but we did not get a click to it did fail. So we didn't see it fail because we caught the exception, right? So the exception is right here, right? So it did fail, and it says that we basically failed because we are networking on a main thread. So in other words, you're not allowed to, you can see it's super tiny, but you're not allowed to block your app while you're trying to connect to the network, because lots of things could go wrong while you're trying to connect to the network, right? Network not available, etc. So what we're supposed to do is we're supposed to do this on a separate thread, okay? So what we're going to do that is we're going to create an asynchronous task. This is an Android construct which basically shrink wraps working with threads. So it creates a separate thread, does the job on a separate thread, comes back to our application. So let me show you that. So basically, what I'm going to say private, or I'll just basically say class post task. So I'm creating an instance of async task, right? Asynchronous task. And I'm going to say this task takes a string as an input. I'm sorry? Yeah, typo. So I'm saying that basically we are taking string as an input, that we have no progress report, because posting to Twitter is atomic, so we don't really know, hey, you posted 50%. And that we're returning string as the output. Okay, so this is an Android construct, but it's basically wrapping a thread around it. So now what we're building this task, and essentially whatever we do here is going to execute on a separate thread. So it's going to solve this problem of concurrency that we currently have. So what I'm going to do is we get the parameters here. And what I'm going to do is I'm going to take this block of code, which is giving me problems because I can't run it on the UI thread. I can't run it on my main thread. I'm going to move this block. That's not what I wanted to do. I'm going to move this block down to here, to this asynchronous task. Right? So whatever was here, which was not allowed because this was running on a UI thread, is now doing background, which is now happening magically on a non-UI thread so that we can do networking. So we're going to get parameters as an array of strings. So I'm going to basically say I want params 0. So I want just the first parameter. And now I'm going to post this. Okay. Now, if we were successful, I'm going to return, I'm going to say return successfully posted. Okay, and if we failed, I'm going to return failed to post. Okay, so basically now I have a piece of code that runs on a non-UI thread, and I try to post. If it succeeds, it's going to say successfully succeeded. Otherwise, it's going to say it failed. Okay, and now what I need to do is I need to kickstart this. So when you click on click. Okay, let me actually, this line doesn't belong here. It belongs here. When I click on click, what I'm going to do is I'm going to create a new instance of this task, post task. So post task. Okay, and I'm going to say execute tweet. So I'm going to basically post this tweet. So essentially here I'm kickstarting that, which is then going to go ahead and execute this. Now this is going to fail again, so just FYI. So, but for a different reason. So I'm starting it. So there's my app. So I'm going to say hello. Click on tweet, and this failed again. You don't see it because we're hiding the fact because we are catching the exception. But if you look at the logcat, you can basically see that we failed. In this case, for a different reason, and that's permission denied. Okay, so essentially in Android, when you're trying to do, Android uses sort of like a very restrictive security model. It's a so-called paranoid network security, right? So unlike your laptop, where if you have network, everything has network. On Android, connecting to network is considered potentially dangerous, right? Because not everyone's got a free internet connection. So it could cost you money. So if an application wants to connect to the network, it needs to ask for a user for that permission at install time. So you know when you download an app, like a game, and it says this app wants to use the internet, read your contacts, write files to your file system, et cetera, et cetera. So those are like permissions. And you as a user say yeah or nay to all of them only once at install time, right? So essentially for us to access network, we must specify, we must ask user for permission. So to do that, what I'm going to do is I'm going to open up our manifest file. Remember, the manifest file is sort of the meta information about your app, the big picture, like components and which version and et cetera, et cetera. So in here, what I'm going to do is I'm going to basically say that we use a permission with a specific name. So there are basically some well-known permissions that Android comes with, and one of the more common ones is this one that I just mentioned called Internet. So that basically now signals to the operating system when you try to install this app that like, hey, this app wants to use your network. Are you okay with that? And you as a user have to say yes, otherwise the app won't install at all. So now during the development stage, you're not going to see this being asked for you, because it would be kind of annoying asking us every single time as we're like deploying 15 times a minute, right? So instead of doing that, it just automatically grants it. But if I was going to take the very same app, put it into Android Market, and you download it, it would certainly ask you. Okay, so what I'm going to do next is I'm going to redeploy this app now with this permission. Okay, and so this permission is now going to be implicitly granted to the user. So there it is. There's the app. Okay, and I'm going to basically say hello from IEEE, and I'm going to post. Okay, and so now if I go and refresh my timeline, there it is. It worked this time around, right? So it actually, my app did post that. And now, you know, same thing would actually be if I connected it via a USB key. So just so you kind of, you know, so that it's not some magic. So if I connected my device, hopefully it just reads it, and go and deploy it. So I would just now connect my device. I say run as Android app. Now my computer should identify my device, but it didn't, and that's sometimes a problem with the ADB. So a quick fix is ADB devices. It doesn't see my device, so I'm going to say ADB kill server. Tools are not perfect. Now I'm restarting the connectivity between this, and for some reason it's still not seeing my device at all. I'm not sure exactly why. Could be the cable. Connect as a media device. It should be connected, but it's not seeing my device at all. Anyway, it would be identical to running on a physical device if you just enable it via USB. So that's kind of that in a nutshell. Creating an application, deploying it on a device, and basically binding the UI. So basically what we've done is we created the UI as an XML. We dragged and dropped a bunch of things, right? Specify some cosmetic stuff, basically how much the positioning of the elements. And again, this is like an Eclipse bug here. It's not showing nicely. And we then bound it to Java by giving it the IDs, by giving this widget's IDs. As a matter of fact, Eclipse already gives you an ID, but it's just a generic button 1, button 2, and so on. So we gave them nice IDs. And then what we did in Java is we found those widgets. So first we inflated XML. We got XML into Java memory space. Then we found the widgets that we care about. So for those of you familiar with JavaScript, this would be sort of like, you know, find element by ID in JavaScript. And then we attached the listener. We basically said the button that we found should notify tweet activity via on-click interface when it gets clicked. And then basically in on-click, we basically said, all right, well, we want to post this to the cloud. But we had this issue of networking on the UI thread. So to deal with that, what we did is we created so-called asynchronous task. An asynchronous task is basically outsourcing the job of networking on a separate thread, right? So that we're not blocking the UI thread. And that task is now using just a generic library that does a RESTful API to, in this case, Yamba, which is based on Twitter. But the same idea is just about with any other web service. It could have been Facebook or, you know, weather forecast or Google Translate or Google Currency or whatnot. So same idea. So and the only other thing that we had to do is we had to enable the permissions because our app was using internet, which is one of the common permissions, and we basically had to request the permissions for that. So that's kind of that in a nutshell, a minimal application from downloading the SDK to something that's actually working and you can actually see the results in the cloud. Questions? Yeah, in the back. Yeah. So the question is, a regular Java program has public static void main. In Android, you're never ever going to write public static void main. That's because in Android, everything is part of a container. Your code doesn't run on. It runs inside of a certain container that has a certain life cycle, and that container is driving your application. So it would be analogous to writing an applet. Did you have a main in applets or servlets? No, because they're running inside of a container, right? The actual main is the browser or Tomcat app server. So in Android, it's something called Activity Manager. That is what instantiates and pokes your callbacks. You provide callbacks. The actual kind of picture for that looks like this. So our activity goes through a set of states, and so this is the life cycle. So something decides to start it, display it on a screen, drive it to certain states, and so on. Yeah.
Now, what if if you've got 4 different aspect ratios and 12 different screen sizes? Does that imply you have to write more than one version of the app? And if not, where is the decision made about how the app gets modified for the different screen sizes and aspect ratios?
Okay, so the question is about, do you have to write multiple apps, multiple form factors? And if not, where does the decision is made? So it's sort of like, again, I'll use the analogy of like a web page. A web page, you write it once. It doesn't matter if it's running in IE or Chrome or Firefox, right? And it also adjusts. It's going to kind of look okay on a phone as well as on a big screen TV as well as on a thing, right? So just to kind of demonstrate, in our application, we made everything be fluid. So if I, for example, rotated the screen here, I'm going to do that, notice that my app is going to redraw itself reasonably properly, right? Like my big box took all the available space. My button is still in the top right corner, so it scaled well. It would also scale well on a TV or a tablet or on a watch. Right? Now you can also do a responsive design. Just like on a web page, you can decide to reorder the elements all together depending on a form factor. So on a phone, you may switch everything to like make it easier. So you can do that on Android as well. Yeah.
So how do you tell the user that the post succeeded or failed?
How do you tell the user that the post succeeded or failed? There are basically 2 other methods that I could have done here. One would be on pre-execute or on pre-execute is where I would turn things on before we even attempt to post, and that happens on a UI thread, so I could communicate to it on a UI. And when I'm done, I could say on post execute, and I could have basically told the user here that it succeeded and failed. This result is whatever we return here. Yeah, so something like new toast, so toast dot make text, and it's just make text. Context would be tweet activity, activity dot this, and the text would be the result, and the duration would be toast dot length long. And dot show. So now basically if I redeploy this, that would tell the user success or failure simply by adding that one line. So that's just basically doing it right now. So testing post tweet, and so we are looking for something here. There it is, successfully posted, and that disappears. So that's kind of like the feedback now mechanism.
So I have a different question also. Does the API support like non-traditional uses? For example, if you have a USB connection to some device that wants to communicate with that, something other than RESTful API?
Does it support something other than RESTful API? Think of it as a standard computer. Like you have a socket. You can open up a socket and communicate whichever protocol you want. So. Yeah, it's basically Java. It's basically you have TCP/IP. You know, you can communicate whichever way you want. Yeah, absolutely. Any other questions?
I'm sorry, new to this. So, how does using Java versus HTML5? Because I saw I'm on an Intel mailing list, and they're all espousing HTML5.
So Java versus, so the question is really native versus HTML5. HTML5 is sort of like you write your app mostly in HTML and JavaScript, shrink wrap it in a tiny bit of native, and the benefit is that your app is going to run on just about any device, from BlackBerry to iOS to Android and so forth. You killed all birds with one stone. But you're limited to a subset of functionality. Native is you're writing just for that device. Way more expensive. But with native, you have way more feature set. As the bar gets higher for what it means to be a great app, we see fewer and fewer people do HTML5. HTML5 is a great tool for certain jobs. You can knock off, like if you're just writing a timesheet app to use internally or something, you don't care what it looks like, and yeah, you can knock off a lot of problems with a simple solution. But if you're hoping to have 1 million users, pay 99 cents, then you should really go with native. Yeah. Any other questions, comments? Yeah, back. So we have.
So I appreciate your comment about native development, but I'm interested in following up on that.
Mm-hmm.
What do you think is the best practice in order to make the most of both the Android market and the iOS market in a single development stream?
What's the best practice to knock off both Android and iOS in the single string? I mean, everyone I work, like companies where mobile is significant, I see doing just basically parallel. Just like, if you're Adobe and you gotta, support both Microsoft Windows and Mac, you kind of have to have two separate teams. Sometimes there's certain things that are reusable. I'm seeing companies actually write some reusable code in C. Believe it or not, C is the new portable language. So they write legacy code in C, and then in Java, in Android you can do J and I to C, and in iOS you can do it's Objective-C, I guess. So it's easy to port. So, but that's kind of there isn't really a lot of overlap right now. Yeah, question. Yeah, PhoneGap. So, question is about the PhoneGap. PhoneGap is a framework that makes making HTML5, JavaScript, CSS apps, web apps. It does that shrink wrapping, and it provides some of the common functionality and so on. So that's what Adobe acquired recently. So yeah, that's one of the solutions. There's Titanium, there's Corona SDK. There are a bunch of solutions like that that exist, frameworks in the market. Yeah.
Okay. So last question. Okay.
Exactly. Yes. Yeah. So native applications tend to be much faster. Yes. I mean, Facebook had a famous switch from HTML5 app to a native app about, I don't know, some year ago or so. And, there's the whole quote, they were quoted how, that was the biggest mistake to ever go with HTML5, blah, blah, blah. But that's when you're kind of operating at that scale, and where that extra percent features and experience and all that is super important. So, yeah. Yeah. Cool. Thank you, guys.
So a big thank you to Marco.
Thank you.